if the function is even or odd. Because if it's odd, the answer will be 0. If it's even, the answer will be twice the integral from 0 to pi over 3 from x to the 4th sine x dx. So, and also, of course, I care about the fact that the function has to be continuous. And the function is continuous between negative pi over 3 and pi over 3. It's a combination of product of two continuous functions. Okay, so now, is the function odd or even? Well, there are only two trig functions that are even. Cosine, and the other one that has only cosine in it, which is secant x. Only these two are even functions. All the other trig functions, sine, tangent, cotangent, and cosecant, all are odd. Every function, every trig function that has sine in it, this one has sine in it, this one has sine in it, and this one has sine in it, they're all odd. So since this is an odd function because x to the 4th is even and sine is odd, the answer will be 0. Okay, any questions? Any questions? Jason, do you have anything from, did you find anything in Weber sine?
No, I think I'm good, actually.
I will go back and just to go back and determine those numbers. I'm curious now about finding the radius and the height for the minimum surface area of that cone. Oh yeah, I'm just curious because we didn't get an answer. I couldn't even solve that equation. I mean, this is it's really weird. Why it didn't even give me an answer? And this is one of the best calculators ever. TI-86, they don't manufacture them anymore because of this feature, which I consider extremely good, the second and Pauli feature. You can put any degree in here, but now I have my doubts. With degree 6 wasn't able to calculate anything. And we saw 4 solutions. And it gives, the calculator gives the imaginary solutions as well, not just the real solutions. But it didn't give us anything. So, anything else? There is only one more topic that we need to cover from this chapter. It's the law of total change. But that can wait for Tuesday. It will not take a long time. It's just the same. We did this before with the particle, determining the distance, total distance of the particle covered from left to right and from right to left. But now we have a different tool. We have the integration to determine that total distance. Anything else we'd like to look at, or I will continue. We still have about 15 minutes. I don't want to waste your time. So I will choose other problems then. Okay, so let's look at more integration. I'm looking at the review exercises at the end, or others. Oh yeah, 34 caught my eye on page 414. So in 34 we have the integral from cosine pi over x squared dx. Any idea about the substitution here? What substitution should we use for this? Well, I don't like functions inside of functions. So we can denote pi over x by u. But can anyone give us du in that case? And remember, we said that this is a very important formula to remember. So it's negative pi over x squared dx. So how do I adjust the whole thing here? No big deal. Multiply by negative pi and divide by negative pi. Very simple situation. So negative pi over x squared with dx, all these will be replaced by du. Yes, with a negative 1 over pi in front. The integral from, so this will be cosine u du. And now this is easy. Negative 1 over pi, which function prime is cosine? Sine u plus a constant c. It's an indefinite integral. I have to go back to the notation. So I have negative 1 over pi sine pi over x plus a constant c. Any questions here? If not, I will choose more problems. Okay, so let's choose another definite integral. Let's say 69 on the same page, 414. The integral from e to the fourth from dx over x, the square root of natural log x. Okay. Again, what I don't like is this natural log inside the square root. And I'm going to test two things here. I'm going to test whether u equals 1 over the square root. If I use 1 over the square root, that's going to be a little bit difficult. So I'm going to just say the square root of natural log x. Let's see what happens. Don't write this for a moment. I'm just testing two different substitutions to see what happens. And of course I have to test whether the function is continuous. So this is continuous between e and e to the fourth. It's not continuous at 0. And here, between e, natural log e is 1, so yes, it is continuous, no problems. So then du will be 1 over 2, the square root of natural log x, times the inner function prime, which is 1 over x dx. And that is the best. I don't have to test the other one. That is the best substitution. So u equals the square root of natural log x. So all this is u. And it doesn't even have, I don't even have to replace it because I have 1 over 2. So multiply by 2 and divide by 2. So I have 2, and I have x, I have natural log x, and I have dx. This whole thing is du. So then we continue with 2. The integral, don't copy the limits of integration. So this is du. Everything here is dx over x times 2 times the square root. And now, when x is e, natural log e is 1, the square root of 1 is 1. When we have natural log of e to the fourth, which is 4, the square root of 4 is 2. And this is 2u from 1 to 2. 2, when I plug in 2, I get 2 minus 1, 1. And that's final. Any questions? Okay. Since you're not saying anything, this really bugs me now. And we had again 81 over pi equals r squared h. So we did get that. And what happens if I use r squared 81 over pi h? So pi, this will be the square root of 81 over pi h. And this will be the square root of 81 over pi h plus h squared. Pi, the square root of 81 squared over pi squared h squared plus 81 h over pi. I didn't think of initially. I thought it would have been easier if I replaced h but not r. I don't know, so I'm trying something here. 81 h over pi. So a prime equals pi 1 over 2 the square root of all that, which I don't care for right now, and I have to differentiate that piece. So we have 81 squared over pi squared, h to negative 2, negative 2 times h to negative 3, plus 81 over pi. So, negative 2, 81 squared over pi squared h to the third equals negative 81 over pi. So 2 times 81, 162 equals pi times h cubed. So h is the cube root of 162 over pi. Okay, if that's the case, then I have h, the cube root of 162 over pi, and a prime of h. Okay, this is always positive. When I plug in, I can't plug in 0 here. I just want to approximate this number. So 162 divided by pi, and everything to power 1 divided by 3. So this is approximately 3.7. So I want to see what happens when I plug in 1. So 1, this is all positive. So with 1, I have a negative 2 times 81 squared divided by pi squared plus 81 divided by pi. Okay, so this is negative, and then I'm going to plug in 4. So 81 squared. No, I want to copy what I have here. So, and put parentheses. Parentheses. No, I didn't mean that. Parenthesis. Never mind. So, parentheses. -2 times 81 squared divided by, in parentheses, pi squared, but multiplied by 4 to the 3rd power, and get out of there, and then plus 81 divided by pi, and I got a positive number. And finally, this is it. Mason, we found it.
Oh, perfect.
Yes, so here it is. So when h equals the cube root of 162, I don't know if you saw what I did. I thought all of a sudden that maybe if I replace r squared in terms of h instead of h in terms of r, because I got such a complicated equation. And once you replace r squared by 81 over pi h, you have to take the square root here, you have to replace it here, and then 2 square roots can be multiplied, so I distributed here and here. And then when I differentiated, it was all so much easier. I only had this equation to solve, and I got this. So this was h, but now r squared. So I have to determine first, so or is just r is the square root of 81 over pi, and this is the cube root of 162 over pi. If I had chosen to substitute r, it would have been done in 10 minutes, 5 minutes. But I chose the other way because I thought it would be easier, but it wasn't. So I will approximate. This is the exact, but I want to approximate. I already did for this one, roughly 3.7, and for this one is this, and I check the signs. This is gold. This is when you realize or you find your mistakes. If you don't do this, anything can happen. So the square root, and we have 81 divided by pi, and further divided by, oh, I want parentheses. Okay, and further divided by, in parentheses, 162 divided by pi, divided by pi, and this raised to 1/3. So the radius is approximately 2.631. See, 2. And they're all in centimeters. Yep. The idea wasn't bad, but the calculations were horrendous. So this is much easier.
Sweet.
All this time in the back of my mind I was, yes, Mason, go ahead.
Oh, no, I was just saying sweet.
Oh yeah, so all this time in the back of my mind I was saying, okay, maybe I did something wrong, but then I said, oh, let me try that. And it works so much better. Look at, a page, and not 5. So these are the correct answers. I checked with the sign of the derivative. It is the minimum. So now you know that if you want to use, make a cup of water for yourself, make sure it's in the form of a cone with a height of 3.7 centimeters and the radius of 2.6, and you will use the least amount of material.
Perfect.
Yeah, sorry about that. My apologies. Any questions? So we have only one tiny topic left for Tuesday.